We'll pause it there. And we line up two we line up two peaks of crests. You can see here, this line right here is 170. So I think we were pretty darn close, if not spot on. E, change the density to 1.5 kilograms per meter and click play. Based on the wave speed, what do you expect the wavelength to be? So we are keeping everything the same, but we're going to increase the density by half a kilogram per meter. Based on the information that we got up here for number 2, what do you think will happen when we increase the density? Okay, make a prediction, and then you can measure that wavelength to check. Okay, when we move on to number 4, we have some data to gather. We're going to click reset and turn off show rulers. The power of a wave is the amount of energy it transmits each second. The power of the wave is displayed below the spring when play is pressed. Record the wave power for each of the settings below. Alright, so we're going to head over to our Gizmo, and for our first one, we need our amplitude at 20 centimeters. We need the frequency at 0.6 hertz. We need our tension at 2 newtons. And we need our density at 1 kilogram per meter. So we're going to click play. And you can see right here, the wave power is 0.402 watts. Okay. So the power for the very first one is going to be 0.402 watts. For our second one, we need to change the amplitude to 40 centimeters and see what happens. And now our power is at 1.61 watts. So for the second one in your table, our power is 1.61 watts. Let's hit reset. Okay, for our third one, we need our amplitude back at 20. And now we are changing our hertz to 0.5. And we see our power here for the third one down on the list is 0.279 watts. We're going to hit reset, and we're going to put our hertz up to 1. All the way up to 1. We're going to hit play. And we see our power for the fourth one down on our table is 1.12 watts. And now we need our frequency back at 0.6. And now we are switching our tension to 2. We have our newtons at 2, which we already do. We're going to hit play. And we see we end up with a power of 0.402 watts. 0.402 watts. So for our fifth one down in our table, our answer is 0.402 watts. Let's reset, and we now need our tension set to 4 newtons. Alright, now we see our wave power for our sixth one down on our table is 0.568 watts. 0.568 watts. Okay, let's get our newtons back to, our tension back to 2, I should say. Now we are changing the density to 0.5. We're going to hit play. And for our seventh one down on our table, our wave power is going to be 0.284 watts. 0.284 watts. Now we need our density back at 1. And again, with our density back at 1 for our last reading in our table, we have 0.402 watts. Okay, so now we are done with our table for number 4. And you need to answer the question, which factors increase the power of the wave? Okay, so which one of these factors that we tested out, the amplitude, the frequency, the tension, the density, okay, which one of those increase the power of the wave? Once you're done answering that question, we move on to number 5. We're going to click reset. We're going to select longitudinal waves. We're going to set the amplitude to 20 centimeters, frequency to 0.6, tension to 2, and density to 1. And we're going to click play. We need to record the power of the longitudinal wave, and then we're going to compare it to that of a transverse wave and see how those two compare to each other. Let's head back to the Gizmo. All right, we have selected longitudinal. We have an amplitude of 20. We have a frequency of 0.6. We have a tension of 2 newtons, and we have a density of 1 kilogram per meter. All right, we are going to hit play. And our power is 0.402 watts. Okay, so our answer for 5A is 0.402 watts. Now we need to compare this to the power of a transverse wave with the same settings. So if we look back up at our table, and we look for our longitudinal or our transverse wave with the same settings, okay, that should be the very bottom one from our table. And we're going to compare the two. So are they the same? Are they different? If they're different, how so? It's asking you, does changing the type of wave affect its power? Okay, so that's going to be your answer for 5B. And we go back to our lab. And the last 2 questions you need to answer for activity B are 6 and 7. So sound waves are longitudinal waves that can travel through air. Would you expect sound waves to travel faster through a low density gas, such as helium, or a higher density gas, such as carbon dioxide? Justify your answer based on what you have learned. So looking back at our table from number 4 or number 2, hey, you need to tell me whether you think sound waves are going to travel faster through a low density gas or a high density gas. And then for number 7, as ocean waves approach the shore, friction with the ocean bottom causes them to slow down. If the frequency is the same, how will this affect the wavelength of the waves? So waves in water, when they get closer to the shore, okay, they interact with the ocean bottom. That they interact with that friction, and you need to tell me how this is going to affect the wavelength of the wave. All right. Once you do that, you will be done with activity B.